Good evening everyone, good evening. Welcome you all again to VJE Enthuse. I hope all of you are doing great, having a good time. So people, before starting the session, you guys can just let me know in the chats if I'm perfectly audible and visible to everyone. Just let me know in the chats fast. Hello Priya, hello Archana, hello Jeffrey, hello Shakti, hello Sandeep, hi Aisha, hello Venkata, hi Naveen. Welcome back, all my people, welcome back, welcome back. Just give me some green signal from the chats so that I'll get to know that I'm audible and visible to you guys properly. Yes? Let me know fast, people, let me know fast. Good evening, good evening, good evening, all my lovely students, good evening. Good evening and welcome back to VJE Enthuse. Yeah? Just give me a second, let me fix the things, we'll be starting. Just let me fix the things, we'll be starting. All right, so people, as you all must be knowing, tonight we are going to do some short questions, right? For the ones who are going to write the CBSE Term 1 examination for chemistry tomorrow, right? As you all must be knowing, we on VJE Enthuse, me, Shimon sir and Shreyas sir, we actually started this series for JEE Mains, right? And now we are continuing the same series for the CBSE students as well, okay? Well, in that night session, I have come up with around 100 questions, right? And I would want you guys to understand and remember those questions properly. And you guys will be expecting those questions for the tomorrow's CBSE Term 1 examination, right? You'll be expecting similar pattern of questions, right, in the tomorrow's CBSE examination. Perfect. So I think I'm perfectly audible and visible to everyone. Well, the ones who have just joined in, the ones who are new to the channel, let me quickly introduce myself. Well, people, my name is Wassim and I'm your chemistry master teacher right here on this VJE Enthuse channel, right? Well, the ones who have not liked the video yet, please do like the video, share the video with your friends, do subscribe to the channel, and do not forget to hit the bell icon so that you get the notification of every single session which we take live on this VJE Enthuse channel, right? So do like the video, share the video with your friends, and do subscribe to the channel right now, okay? So first of all, you guys can let me know in the chats if you all are super duper excited about the tonight's session. Yes, let me see the Josh of the session first. Yeah? Let me know fast in the chats, my dear people, if you all are super duper excited about the tonight's session. Yes, I'm doing wonderful, guys. I'm doing wonderful. Thank you. Just let me know in the chats fast if you all are super duper excited about the tonight's session, and the ones who have not liked the video yet, do like the video, share the video with your friends, do subscribe to the channel so that everyone gets benefited out of these sessions. Yeah? Right? So, well, I can see your chats. I think people are super duper excited and ready for the session, for the short session. So let's get going then. Let's get started from the chapter solid state first, right? The first question from the chapter solid state is going to be on your screen in 3, 2, 1, and now. This is the first question which is on your screen. I want you guys to let me know the answer of this question in the chats. Let me know its answer. It's a very simple question. We have got a particular solid. A particular solid is hard and has a high melting point. In solid state, it is non-conductor. Its melt is a conductor of electricity. Identify the solid. Identify the solid. Let me know quickly its answer in the chats. Well, absolutely, as you all are perfectly right. I can look at the chats and see people are coming up with the option C. It's absolutely going to be the ionic solid, right? When you particularly talk about the ionic solid, in solid state, it's going to act like the insulator. In solid state, it's going to act like, it's going to behave like the insulator. And in aqueous and molten state, it is going to behave like the conductor, right? And this is basically valid for what? It is valid for the ionic solid. So ionic solid, whenever it's in particular solid form, it behaves like the insulator. When it will be in molten or aqueous form, it is going to behave like the conductor. I'm sure this is clear to everyone, right? Let me move on directly to one more question. It was a very simple question, theoretical one. Okay, one more question on your screen. I want you guys to give it a try and let me know its answer quickly in the chats. Well, I'm looking at your charts only. Give it a try. First, which of the following is correct for total volume of atoms present in FCC unit cell? What is going to be the correct answer of this question? What is the total volume occupied by the atoms in case of face-centered cubic unit cell? What do you think about this one? Well, I can see majority of the students are coming up with option B, and let me quickly show you what is going to be the correct answer of this question. Let's try it out. Well, first of all of you are perfectly correct. It's going to be option B only, yeah? And say exactly how come it's going to be option B. For example, I'm making a face-centered cubic unit cell over here. Let's assume this is your face-centered cubic unit cell in which the constituent particles are present at the corners, and at the same time, the constituent particles will be present at the centers of each faces. Centers of each faces. This is the center of front face and this is the center of back face, right? As you all must be knowing, the contribution of the corner particle towards the unit cell is 1/8 and the contribution of face-centered particle towards the unit cell is 1/2, right? Let's assume the radius of this constituent particle is r, right? Let's assume the radius of the constituent particle is r. What do I need to calculate? I need to calculate the total volume occupied by the constituent particles in this unit cell, correct? See how I'll be calculating it. Simple. First of all, if I talk about the corner particle, can I say only 1/8 part of this corner particle will be inside this cube? Absolutely, right? What is the volume of this whole corner particle? It is 4/3 pi r cube. This is the volume of the complete whole corner particle, right? But only 1/8 part of this volume will be inside this cube, so I'm multiplying it with 1/8, right? Apart from the corner particle, see first of all, this is basically that volume of the corner particle that lies inside this cube, and similarly, we have got some 8 corner particles like this, so I'm multiplying this by 8. If I ask you what about this term, what is this term going to be? This term is giving me that volume of all the corner particles which lies inside this cube, right? Apart from this, we have got the face-centered particles as well, right? Well, only half of this face-centered particle will be inside this cube, so I'll be writing 1/2 multiplied by 4/3 pi r cube. This is the volume of one face-centered particle which lies inside this cube, and similarly we have got some 6 face-centered particles like this. Okay, so once you solve it, you'll be getting the value exactly as 16 divided by 3 pi r cube. As simple as that, right? Yes, right, people? So I'm sure this is clear to everyone. This term is giving you that volume of all the constituent particles which lies inside this cube. As simple as that. Okay. Let's jump into one more question. This is one more question which is on your screen, and I want you all of you to give it a try and let me know its answer quickly in the charts. I'm looking at your charts. Yes, Rahul, you can do it in that way as well. Absolutely. What is going to be the answer of this question, people? The sharp melting point of a crystalline solid as compared to amorphous solid is due to. In crystalline solids, we have got the regular arrangement of constituent particles over a long range. In amorphous solids, there can be the regular arrangement, but that is in a short range, correct? So what is going to be the answer of this question? Well, I can see majority of the students are coming up with option D, and let me tell you, absolutely you all are perfectly right, right? Yes, the sharp melting point of crystalline solids, what is the reason for that? The reason is the regular arrangement of constituent particles observed over a long distance in case of crystal lattice. In case of what? In case of your crystalline solids. In amorphous solids, there is no long range order, there is short range order, right? And that's why amorphous solids do not have the sharp melting points. Perfect? Absolutely, my dear people. Wonderful. Moving on to one more question. This is one more question. Kill this one, right? Let me know quickly its answer in the charts. I'm looking at your charts only. Each ion or atom that forms a face-centered cubic unit cell is surrounded by. Each particle in FCC is surrounded by how many voids? How many octahedral voids? How many tetrahedral voids? Let me know quickly its answer. I want you guys to let me know its answer quickly. I want you guys to let me know its answer quickly. Yes, you can do it. Well, not many people are coming up with the correct answer. The correct answer is not going to be option A, people. The correct answer is not going to be option A. Absolutely few of you are coming up with option D, and let me tell you, D is absolutely the correct answer, right? Well, in case of face-centered cubic unit cell, each constituent particle will be surrounded by 6 octahedral voids and at the same time 8 tetrahedral voids. Okay, do remember this thing as well, because you know in case of FCC, octahedral voids are present at the edge centers, right, and at the body center. And in case of your FCC, your tetrahedral voids, they are present at 1/4 of the body diagonal. So basically, in case of FCC, each constituent particle will be surrounded actually by 6 octahedral voids, right, and 8 tetrahedral voids. Correct? I want you guys to remember this one, okay? And I'm sure you are going to remember it. Now, people are saying, why? Okay, you want me to answer this? Have a look. See, guys, if you look at face-centered cubic unit cell, if you look at the face-centered cubic unit cell, let's say I'm drawing a face-centered cubic unit cell. Just a second, let me draw it properly so that you can understand it properly. I'll be just showing you the octahedral voids. Have a look. See, guys, if I talk about the face-centered cubic unit cell, these are the corner particles first of all. And apart from these corner particles, we have got the face-centered particles as well. They'll be present at the center of each face, correct? Yes. Now, in case of FCC, where do we have the octahedral voids? We have got the octahedral voids present at the edge center, right? First of all, just behind this cube, on the left-hand side of this cube, there will be one more cube whose top surface will be this one, right? Yes, this is one more cube whose top surface is this one. Just behind this cube, there'll be one more cube whose top surface will be this one, right? And on the side of it, there'll be one more cube whose top surface is this one, correct? And similarly, there will be 4 more cubes present on the top of them. There'll be 4 more cubes present on the top of them, like this, right? So total, there are basically 8 cubes. Total, there are basically 8 cubes, right? If you talk about this particular particle, this particular particle is surrounded by how many octahedral voids, which are equidistant from it. Let me tell you, this particular particle is actually surrounded by 6 octahedral voids. And have a look exactly. See, at this edge center, there will be octahedral void. At this edge center, there will be octahedral void, right? At this edge center, octahedral void. At this edge center, octahedral void. At this edge center, octahedral void. And at this edge center, octahedral void. So basically, there are 6 octahedral voids which are equidistant from this particular particle. So this particular particle is actually surrounded by 6 octahedral voids. I'm sure this is clear to every single guy. And similarly, there will be 8 tetrahedral voids surrounding a particular particle in case of FCC. Yeah? Yes? I'm sure it's clear to every single guy now. Okay? Let's jump into one more question, my dear people. Which of the following compounds is likely to show both Frankel and Schottky defect? It's a very common question, and this question has been asked many a times in your JEE mains as well. And I'm sure you'll be remembering it. Yeah? Let me know first. It is absolutely going to be AGBR, which shows both Schottky as well as Frankel defect, right? Yes? Exactly, guys. It is going to be your AGBR, which actually shows both Schottky and Frankel defect. This question has been repeated many a times in your JEE mains examination as well. So do remember this from now onwards. Yeah? Perfect? Absolutely. Moving on to one more question. Okay. Which primitive unit cell has unequal edge lengths? A is not equal to B, is not equal to C, and all the axial lengths, alpha, beta, gamma, different from 90 degree. This is the one which I told you in the last session to remember directly from NCERT. And on NCERT, there's a page given, okay, in which you are given with the crystal systems, right? Total, there are 7 crystal systems, cubic, tetragonal, orthorhombic, and so on, correct? Yes? What do you think about this one, people? What do you think about this one? Let me know. Let me know the answer in the chats. I'm looking at your chats only. Well, absolutely, majority of the students are coming up with the right answer. It's going to be option D. In your triclinic crystal system, your edge lengths A is not equal to B, which is not equal to C, and all the axial lengths, they differ from 90 degree, right? It is possible in triclinic, right? There is a separate page given on your NCERT. I want you guys to remember that, okay? Perfectly done. Let's move on and let's jump into one more question, my dear people. Look at this question. In a face-centered cubic lattice, atom A occupies the coordinate positions. Atom B occupies the face-centered positions. If one of B is missing from one of the face-centered points, the formula of the compound is going to be. What do you think about this one? You need pen and paper for this? Absolutely, you need it, right? So solve it and let me know quickly its answer. Quickly, I want you guys to let me know its answer first. Yes? Well, I can see majority of the students are coming up with option D. Let me exactly check, is it going to be option D or not? Have a look, guys. See, First of all, in a face-centered cubic lattice, we have got two atoms, A and B, right? As per the question, A atoms occupy the corner positions, A atoms occupy the corner positions, and B occupies the face-centered positions. B occupies the face-centered positions. If one of the B atom is missing, right, from one of the face-centered points, the formula of the compound will be very simple and basic. A particles are present at the corners of the cube. Contribution of the corner particle towards the cubic unit cell, 1/8. Total there are 8 corner particles multiplied with 8, right? Contribution of the face-centered particle towards the cubic unit cell, that's 1/2. Total there are 6 face-centered particles, but out of 6, 1 is missing, so I'll be left with 5 only, right? So I've multiplied it with 5. So this value will come out to be 1, and this value will come out to be 5/2. If I multiply with 2 here, the value comes out to be 2, the value comes out to be 5. So the correct formula is going to be A2B5. Yes, people, A2B5. All of you are perfectly right. It's option D, which is the correct answer. Yes? Perfectly done. Absolutely, my dear people. Absolutely, absolutely. You all are perfectly right. Wonderful. Good job done. Moving on to one more question. This is one more similar sort of question, and use the pen and paper and kill this question and let me know its answer right now in the chats. I'm looking at your chats only. First, in a compound, atoms of element Y form CCP and those of element X occupies 2/3 of tetrahedral voids. What is going to be the formula of the compound? What do you think? What do you think? Fast, people. Fast. Do not take a lot of time. It's a very simple and basic question. Yes, you can kill it. Well, I can see majority of the students are coming up with option A, but I need to check it. Is it actually going to be option A or not? Let's check it, my dear people. Have a look exactly. So first of all, whenever in a question, you'll be written with CCP. It's given as CCP, cubic close packing. Do remember, CCP is nothing, CCP is FCC, right? And I hope you remember, in case of FCC, the value of Z is 4. Effective number of particles, effective number of atoms, in case of FCC is 4. And do remember, whatever is going to be the value of Z for a unit cell, same is going to be the number of octahedral voids, and twice of it is going to be the number of tetrahedral voids, right? This is something which every one of you would be knowing. I'm sure about that, right? Now see, in a compound, atoms of element Y form CCP, right? Atoms of element Y form CCP. That means they are present at the corners and at the face centers, right? CCP. Correct? Let me write it over here. They are forming CCP. CCP means FCC, corners and face centers. And similarly, atom X occupies 2/3 of tetrahedral voids. 2/3 of tetrahedral voids. Yes? What will be the formula? Have a look. First of all, Y particles, they are forming FCC. For FCC, what is the value of Z? That's 4. So I'll be directly writing 4 over here. X particles, 2/3 of tetrahedral voids. Tetrahedral voids total, there are 8, right? So 2/3 of 8. So let me just quickly solve it. It's going to be 1. This is going to be 2. So the value comes out to be 1:4/3. If I multiply throughout by 3, multiply this with 3, I'll be getting the value as 3, and 3:4. So Y is going to be 3 and X is going to be 4, right? X4Y3. So option A is going to be the one which is correct, right? Yes? Right, people? So I'm sure this is clear to everyone. Yes? Perfectly done. Should I be jumping into one more question? You want me guys to move on to one more question? And the ones who have not liked the video, please do like the video, share the video with your friends, and do subscribe to the channel. Okay, one more thing. Before going into the next question, let me tell you one important thing. Tomorrow, right after your examination, I'll be coming up with the paper discussion, right? Exactly at 1:45 sharp, I'll be coming up with a paper discussion, but that paper discussion I'll be doing live on another channel, that is NEET Elite, right? That is NEET Elite. On NEET Elite channel tomorrow at 1:45 sharp, I'll be coming up with a paper discussion. I'll be doing the paper discussion live from this channel, okay? Perfect? Do remember it. If you have not liked the NEET Elite channel yet, do like it. Do subscribe to the channel first, right? Yes, so that we can meet up there as well tomorrow, okay? Moving on to one more question. Have a look. Kill this question, people. It's a very simple one. Assertion: a tetrahedral void is surrounded by 4 spheres, whereas octahedral void is surrounded by 6 spheres. It's absolutely right. A tetrahedral void is formed when 4 particles touch each other, right? And the octahedral void is formed when 6 particles touch each other. Correct? The coordination number of tetrahedral void is 4, and the coordination number of octahedral void is 6. You guys must be knowing this, right? So this is absolutely correct. Reason, the number of tetrahedral voids, is double the number of close packed spheres, right? Is double the number of close packed spheres, and the number of octahedral voids is equal to the number of close packed spheres. As I told you, whatever is the value of z, same is the number of octahedral voids. Whatever is the value of 2 times z, same is going to be the number of tetrahedral voids. So what is going to be the correct answer of this one, people? Absolutely, your assertion is true, your reason is true, but the reason is not the correct explanation of your assertion, right? Yes? Correct? The reason has got nothing to do with the coordination number of tetrahedral and octahedral void, right? So the reason is not the correct explanation of assertion. I'm sure this is again clear to you. I'm moving on directly to one more question without wasting a lot of time for you, because you have got the test tomorrow and we need to finish this session just in 2 hours, okay? Frankel defect is shown by ionic substances in which cation and anion are of almost similar size. Do you think this is right? Let me know fast, quickly. Do you think this statement is right? Do you think this statement is right? Fast. Okay, let me just tell you. If I talk about the Schottky defect, Schottky defect are shown by the compounds which have got the high coordination number, and small difference in the size of cation and anion. Small difference in the size of cation and anion, right? And if I talk about Frankel defect, Frankel defect is generally shown by those compounds which have got small coordination number, low coordination number, and large difference in the size of cation and anion. So this statement kills this statement, right? Reason, Frankel defect is also called as dislocation defect. Is it right, my dear people? Is it right? Let me know fast. Absolutely, you all are perfectly right. It's going to be option D. Your assertion is false, but the reason is absolutely true. Yeah? All of you said option D, and absolutely it's option D. Moving on to one more question. This is one more question. Kill this one. Face-centered cubic cell has 4 atoms per unit cell. Is that? Yes, absolutely right. In case of face-centered cubic unit cell, constituent particles are present at the corners and at the face centers, right? So 1 by 8 multiplied by 8 plus 1 by 2 multiplied by 6 makes it 4, right? And similarly, reason, in face-centered unit cell, there are 8 atoms at the corners and 3 atoms at the face centers. What nonsense he's saying? 3 atoms at the face centers? No way, right? So assertion is absolutely right, but the reason is false. So A is true, R is false. So C is going to be the answer. Okay, let me quickly know the answer of this question, my dear people, fast. I'm looking at your chats only. I am looking at your chats. Well, I am seeing majority of the students have not liked the video yet. Guys, please do like the video, share the video with your friends, and do subscribe to the channel as well. Okay, do it fast, kill it. Well, people are coming with option A, and absolutely all are right. Which of the following does not show Frankel defect? It's going to be KCl, which does not show Frankel defect, right? Which does not show Frankel defect. Yeah? The reason I told you a few minutes back, which all compounds show the Frankel defect and which all compounds show the Schottky defect. The reason I told you a few minutes back only. Yes? So it's absolutely going to be option A, right? It's absolutely going to be option A. In KCl, the size of anion and cation are similar. If the size of cation and anion is similar, so what is going to be the size difference between cation and anion? It's going to be small, right? It's going to be small, yeah? Right? And wherever the size difference of cation and anion is going to be small, that shows Schottky defect, not the Frankel defect, right? Few minutes back we have seen it. Perfect? Okay, moving on to one more. In which of the following crystal metal deficiency defect is present? Metal deficiency, just remind the things which you have discussed. In which of the following crystal metal deficiency defect is present? Which one among them shows the variable valency? Which among them goes from di-positive to tri-positive? Which of them goes from di-positive to tri-positive? In case of FeO, my dear people, in case of FeO, correct? In case of FeO, one of the Fe di-positive will be leaving the crystal and other Fe di-positives will get converted automatically into Fe tri-positives, correct? Which eventually leads to the metal deficiency defect, right? Statement directly given in NCERT. It's option B which is going to be the correct answer of this one. Well, majority of the students have already said so. Good. Perfecto. FeO is the example of metal deficiency defect because Fe dye positive cations are missing from the FeO crystal and the loss of positive charge is made up by Fe tri-positive ions. Correcto? Yes. Moving on to one more. Schottky defect in a crystal is observed when? This is something which every one of you would be knowing, right? I would want you guys to flood the chat box with the correct answers. Fast people. I would want all of you to flood the chat box with the correct answers. Yeah? Absolutely. In case of Schottky defect, what happens? Equal number of cations and anions will be missing from their sites. Right? Yes? Perfectly done. It's going to be option C, which is the correct answer of this question. Wonderful. Okay. Let's jump into solutions. These are the questions, right? These are the questions which you guys are going to remember, and do expect the similar type of questions in the tomorrow's examination, right? And right after your examination, I'll be doing the live paper discussion at sharp 1:45 on NEET Elite channel, right? Perfecto. The first question which is on your screen from the chapter solutions, kill this one. I want you guys to kill this one, yeah? I'm not going to solve this. Kill this one fast. Fast people, fast. Fast. Yes. I'm looking at your chats only. What do you think about this one? People flood the chat box with the correct answers. Yes, I want answers from you. Yeah? That's great. Wonderful. Okay, let's have a look, people. As you all must be knowing, whenever I'll be having a solution which contains two volatile substances, right? The total vapor pressure of that solution is going to be the sum of their respective partial pressures, Pa plus Pb. Correct? For example, Pa plus Pb. Yeah? As per Raoult's law, Pa is nothing that is P naught A multiplied by chi A. Pb is equal to P naught B multiplied by chi B. And all of you must have heard about something as chi A plus chi B is equal to 1. So I can write, instead of chi B, I can write 1 minus chi A, right? If I just rearrange this, so total vapor pressure of the solution will be equal. It's going to be equal to P naught A multiplied by chi A. It's going to be P naught B minus P naught B multiplied by chi A. Have a look. Over here we have got chi A. Over here we have got chi A. If I take chi A common in these two, what I'll be getting? I'll be getting PS is equal to P naught B plus P naught A minus P naught B multiplied by chi A, right? I'll just shuffle the equation, that's all. Yeah? So I think this is the one, yeah? People, done, dusted, yes? Right? Perfecto. Moving on directly to one more question. An azeotropic solution of two liquids has boiling point lower than either of the two liquids, right? Yes? What is going to be the answer of this question? Kill it fast. When it shows no deviation from Raoult's law, when it shows negative deviation from Raoult's law, when it shows positive deviation from Raoult's law. Minimum boiling azeotropes, what? Is it related to the solution showing positive deviation or negative deviation? Minimum boiling azeotropes related to solution showing positive deviation from the Raoult's law. Absolutely, the point is given in your NCERT, my dear people. Yes? So you all are perfectly right. It's going to be option C, which is going to be the correct answer of this question. Wonderful. Moving on to one more. This is one more. Kill it fast. The density of 2.05 molar solution of acetic acid in water is 1.02 grams per ml. The molality of this solution will be. Well, people, let me just give you one direct relation between molality and molarity. So remember it from now onwards. One direct relation, yeah? Molality is always equal to 1000 multiplied by molarity of the solution divided by 1000 multiplied by density of solution minus molarity multiplied by molar mass of solute. This is one direct result between molarity and molality. I hope you guys are going to remember it from now onwards, yeah? What am I supposed to calculate? I need to calculate molality. This is something which I need to calculate. Do I know the molarity value? Yes, we are given the molarity of the solution. Do I know the density of solution? Yes, we know the density of solution. Do I know the molarity of the solution? Yes, we know the molarity of the solution. Do I know the molar mass of solute? What is solute? Solute is your acetic acid, CH3COH, right? You can calculate its molar mass. You can calculate its molar mass, right? So molar mass of solute is also, which is given, right? So all the parameters which are required in this equation are given to me, so I can easily calculate molality, yeah? Right, people? Yes? So finally, the answer you'll be getting as 2.28 molal. That is going to be the correct answer, which you'll be getting if you use that equation, and it's going to minimize the time of solving the equation. Yes, it's going to minimize the time for solving the equation. Yeah, perfect. So you want me guys to move on to the next one? 60 is the molar mass of solute. 60 is the molar mass of your acetic acid, right? Perfecto. Let's move on to one more question, my dear people. Which of the following statement is false? I want you to solve this. It's a complete theoretical question. Units of atmospheric pressure and osmotic pressure are same. Pressure, absolutely. Yes. Yes. Shifaya, it was M2, which was molar mass of solute. In reverse osmosis, solvent molecules move through a semi-permeable membrane from a region of lower concentration of solute to a region of higher concentration. And over here it is mentioned as reverse osmosis. Is it correct? Is it correct? It's absolutely incorrect. It's absolutely incorrect. In reverse osmosis, what happens? It is from higher concentration to lower concentration. Actually, it's from higher concentration to lower concentration in reverse osmosis. But the case is given reverse. So option B is the one which is correct among all, right? Killed? Yes, it's high to low. It's not low to high. Low to high is in osmosis, not here. Perfecto. One more. Okay, anoxia is a condition generally seen in climbers. Because of what? Because of what? In mountain climbers, basically, you see this kind of a condition, anoxia. And what is this anoxia? I mean, how it happens? How it happens? How it happens? Because at higher altitudes, air becomes thin, right? Air becomes thin, right? There is low partial pressure of oxygen at higher pressures. Yes, there is low partial pressure of oxygen at higher pressures, due to which the mountain climbers face this anoxia condition. So what is going to be the correct answer? It's absolutely going to be option D, my dear people, right? Moving on to one more. This is one more question on the screen. Raoult's law becomes the special case of Henry's law. When? Fast. This is again given in your NCERT as well. Raoult's law becomes a special case of Henry's law. When? When Henry's constant is equal to P naught, right? Yes, absolutely, all of you are perfectly correct. This question is directly in your NCERT, right? It's given in the form of a statement. Yes, so it's absolutely going to be option A. Moving on directly to one more. Among the following, the azeotropic mixture is. Which of the following will form the azeotropic mixture? How do we check it? How do you check it, my dear people? How do you check it? Fast. Which of the following forms the azeotropic mixture? I want you guys to let me know its answer fast. Yes, kill it. Kill it fast, yes. Is it going to be A, B, C, or D? The one which is going to form the non-ideal solution. Non-ideal solutions only form the azeotropic mixtures, right? It is not the ideal solutions which form the azeotropic mixture. It is the non-ideal solutions basically which forms the azeotropic mixture. And out of all, which of the two forms the non-ideal solution? It is the first one only. Only CCl4 and CaCl3, they form the non-ideal solution. Rest all the ones, whatever is given apart from option 1, all of them form the ideal solution. And in case of ideal solutions, azeotropic mixture is not formed, right? Yes, so over here, it's going to be option A. Because option A is the one where non-ideal solutions will be getting formed, right? Only non-ideal solution forms the azeotropic mixture, constant Boiling mixtures. Among the given, only CCl4 and CaCl3 form non-ideal solution. Thus, they form the azeotropic mixtures, right? Directly jumping into one more question. Kill this one fast. Let me know its answer. And the ones, again I'm telling you, who have not liked the video yet, do like the video, share the video with friends, and do subscribe to the channel as well, yeah? Okay, people. 138 grams of ethyl alcohol. Ethyl alcohol is C2H5OH, right? This is your ethyl alcohol, and we have taken some 138 grams of it, right? Is mixed with 72 grams of water. The ratio of mole fraction of alcohol to water. Okay? How do we calculate it? First of all, let me calculate the number of moles of methanol, number of moles of C2H5OH, right? It's going to be equal to given mass of methanol divided by molar mass of methanol. What is molar mass of methanol? Can you let me know what is the molar mass of methanol fast? Fast, people, I want it in the chats. Can you let me know what is the molar mass of methanol fast? Fast, 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 fast. Do not take a lot of time. What is the molar mass of methanol? People are saying it's 60 or 46. People are saying it's 46, yeah? Okay, it's 46. So this is 1, this is 3. The value comes out to be 3. So I got the moles of methanol. Similarly, the number of moles of water. Isn't it going to be given mass of water divided by molar mass of water? The value comes out to be 4, right? What do I need to calculate? I'll be calculating the mole fraction of methanol. The mole fraction of methanol is going to be equal to number of moles of methanol divided by total moles present in the container, which is 3 plus 4, that is 7, right? Similarly, what about the mole fraction of water? Mole fraction of water is going to be 1 minus 3 by 7, 1 minus 3 by 7, which is going to be 4 divided by 7. I got the mole fraction of each. What do I need to calculate? I need to calculate the ratio of mole fraction of alcohol to water. Alcohol to water, right? So 3 divided by 7 whole divided by 4 divided by 7. So 3:4 is going to be the correct answer, right? So it's going to be option D, which is the correct answer, my dear people, right? Killed it? Yes. And the ones who have just joined it, do not forget to like the video, people. Perfectly, moving on to one more. Okay. What will be the molar mass of protein if osmotic pressure of a solution containing 2 grams dissolved protein per 300 centimeter cube of the solution is 20 mm of Hg at 27 degrees centigrade? Which formula do we use? I'll be using the formula for osmotic pressure, right? I'll be using the formula for osmotic pressure, right? Pi, osmotic pressure, is equal to CRT, right? Pi is equal to CRT. What is C? C is the concentration. Number of moles of solute divided by volume of solution, right? Divided by volume of solution. All the parameters are given, yes? So number of moles of solute, I can write pi is equal to number of moles of solute is going to be equal to mass of solute divided by molar mass of solute, and in the denominator we have got volume, right? And in the numerator we have got R as well as T, correct? What do I need to calculate? I need to calculate the molar mass of solute. Osmotic pressure is given, mass of solute is given, right? Mass of solute is given how much? Mass of solute is given as 2 grams, R value 0.0821, temperature 27 degrees centigrade, volume is also given. So from this you can calculate the molar mass of solute, as simple as that. Let me exactly show you its solution and answer. See, I've used the same relation over here and I've put all the parameters over here. It is just over here, you need to be careful of one thing. This osmotic pressure, it's given in mm of Hg. It is given in mm of Hg, right? And R value you have taken as 0.0821 atm liter per Kelvin per mole. So you are going to convert this mm of Hg into atm, right? You are going to convert this mm of Hg into atm by just dividing it with 760. That 760 goes up, right? Yes, as simple as that. Make sure you do this, okay? Because the osmotic pressure was given in mm of Hg and R value you are using at 0.0821 atm liter per Kelvin per mole. So make sure you convert the pressure in mm of Hg into atm by dividing it with 760, yeah? So do remember this, okay? Moving on and jumping on to one more question. Henry's law constant for molality of methane in benzene at 298 is given to me as this much. What will be the mole fraction of methane in benzene at 298 under 760 mm of Hg? Use the Henry's relation, kill this question and let me know fast its answer. Yes? I'll be giving you some time. Use the pen and paper, kill this. Henry's equation. P is equal to Kh multiplied by chi, right? You are supposed to calculate chi, which is going to be P divided by Kh. P is given to you, Kh is given to you, right? So P is given to you, Kh is given to you. Kill it. 1.78 into 10 raised power minus 3. Yeah? Perfect. I know this involves a little bit of calculation. I know that's why you are taking time in solving this. But this is the concept, right? Yes? Right? You might be thinking I'm super fast, I'm solving the equation fastly. But people, I know you have got less time for the tomorrow's examination. I want to finish the session quickly, right? And I want to show you all the patterns of the questions. The molality of the solution of glucose in water, which is 10% weight by weight. So first of all, 10% weight by weight of glucose. What that means? That exactly means 10 grams of glucose are present in 100 grams of solution. 10 grams of glucose are present in 100 grams of solution, right? So this is basically your mass of solute. This is basically the mass of solute, right? And this is basically the mass of solution. If I know the mass of solute, solution, I can simply calculate mass of solvent as well. Yes, so mass of solvent, first of all, is going to be equal to mass of solution minus mass of solute. The value comes out being 90 grams, right? Now, Use the molality equation. Molality is equal to mass of solute in grams, which is 10, multiplied by 1000, divided by molar mass of solute, molar mass of glucose, which is 180, multiplied by mass of solvent in grams, that is 90, right? Just use it and get the molality of the solution, right? Yes, perfect. Perfect, all my people, yes. Wonderful. So after solving this, you'll be getting the value exactly as 0.617, right? This is going to be the molality of the solution. Yeah? Absolutely. Moving on to one more question. Assertion reasoning is coming. Larger the value of cryoscopic constant. What is cryoscopic constant? It is basically Kf, which you call as molar depression constant, correct? Okay, larger the value of cryoscopic constant of a solvent, lesser the freezing point of the solution. Lesser the freezing point of the solution. Yes? Correct? People, is it clear? Is it clear? And the reason is shown. Extent of depression in freezing point depends on the nature of solvent. What do you think about this one? It's a very simple and basic question, right? Both the statements are absolutely correct. Both the statements are absolutely correct, right? And the reason is actually the correct explanation of first one. It's not B, it's A. Yeah? Yes, Kavi, it's A. Yes, Army, it's A. Right, absolutely it's A. So basically, larger the value of KH, lesser is going to be the freezing point of the solution. And at the same time, reason, extent of depression, it depends on the nature of the solvent which you have taken, absolutely, right? Because KF, freeze cryoscopic constant, it depends on the nature of the solvent. Cryoscopic constant, it depends on the nature of the solvent, right? Yes? Do remember this. Okay? Alright, for ideal solution, AA and BB interactions are similar to AB interactions. Absolutely right. Every one of you would be knowing this. Yes. Reason, in case of negative deviation from Raoult's law, AA forces are stronger than AB, BB forces. Is this statement correct? This is not correct, right? This is not correct. This is valid for what? This is valid for positive deviation. It's valid for positive deviation. This is valid for positive deviation, right? Okay? This is valid for positive deviation. So reason is wrong, but assertion is true. Assertion is true, but reason is wrong. Yes, assertion is true, but reason is wrong. The normality of 1.5 sulfuric acid. Sulfuric acid. If you talk about H2SO4, what about the N factor? What about the N factor of H2SO4 normally? Normally N factor of H2SO4 is 2. 2. What does N factor of acid mean? It means its base state, right? It means its base state. The number of H positive donates, right? And we know normality is nothing, that is molarity multiplied by N factor of solute. Molarity is given to me as 1.5, N factor is 2, the value comes out to be 3, right? So this statement is absolutely correct. This statement is absolutely correct. Reason, normality is equal to the product of molarity and basicity for this acid. Absolutely right. So it's option A. It's option A, my dear people. Yes? Perfectly done. Absolutely. Let's move on to one more question. A person cries more while cutting onion rather than cutting onion which has taken out from the refrigerator. Absolutely, that's right. Yes, absolutely, it's right. Yeah. A person cries more while cutting onion rather than cutting the onion which has taken out from the refrigerator. What is the reason? The cold onion has higher vapor pressure of its volatile content. Yes, absolutely right. Is that? Is the reason right? Is the reason right? The reason is not right at all, right? The cold onion, it will be having lesser vapor pressure of its volatile content, right? Yes? Okay? Right, people? Absolutely. Absolutely. Vapor pressure basically is temperature dependent, right? On decreasing the temperature, vapor pressure decreases, correct? So cold onion absolutely will be having lesser vapor pressure, yeah? Okay, moving on to one more. Okay, moving on to P block questions. First question on your screen. First question on your screen. Which of the catalysts is used in the manufacture of H2SO4 by contact process? People, I'm sure you would have heard about it. It is V2O5, right? It is V2O5. In contact process, we use this catalyst, right? Yes, perfectly done. V2O5. One more. Among the following, maximum number of compounds are known in case of what? In case of xenon. Yes? Among all these noble gases, xenon forms the maximum number of compounds, right? XeO, XeF2, XeF4, XeO2F2, XeOF4 and so on, right? It's going to be xenon. Perfectly done. One more. Identify the compound Nitrogen forms 3 oxo acids. Perfect. Among these, one is most important in terms of laboratory and industrial applications. It is a strong oxidizing agent, right? So first of all, let me tell you, this nitrogen forms 3 oxo acids. And what are those oxo acids? This is the first oxo acid. This is one of the oxo acid. This is one more oxo acid. This is one more oxo acid. Now, among these 3 oxo acids, which one is more important in terms of laboratory, right? And let me tell you, it's going to be HNO3, which behaves as a strong oxidizing agent, right? You all are perfectly right. It's option B. Option B, people. Option B, absolutely. One more. Strongest oxo acid of chlorine. Strongest oxo acid of chlorine. Check the oxidation state of chlorine. Wherever oxidation state of chlorine is maximum, that acid of chlorine is only the strongest what? Oxo acid, right? Where is the oxidation state of chlorine maximum? I think in the first one, right? Over here, chlorine has got +7 oxygen state, right? So HClO4 is going to be the strongest acid among all. Yes? Perfect. Right? In HClO4, the oxidation state of chlorine is +7. Larger the oxidation state, strongest will be the oxy acid of this chlorine, right? Perfect. And on the other hand, the oxidation state of chlorine in HClO2 is +3, in HOCl it's +1, and in HClO3 it's +5, right? Yes? Okay, one more. Which of the following fluorides does not exist? This is a very common question. This is a very common question. I want you guys to solve this and let me know its answer fast. I'm waiting. I'm looking at your chats only. I am looking at your chats only, my dear people, fast. What is going to be the correct answer of this one? Yes, it's going to be HEF4. Have you ever seen HEF4 compound existing? No way, yeah? Right? It's a very simple question. No need to think a lot about this one. Okay, choose the incorrect match. Choose the incorrect match. Ionization energy, correct. Electron negativity, correct. Density, correct. Electron affinity, right? Chlorine has more electron affinity than fluorine, yeah? In the similar way, sulfur has got more electron affinity than oxygen, right? So this is the incorrect form. This is the incorrect form. Chlorine actually has more electron affinity than that of fluorine. Yeah, perfect. Yes, people? Absolutely, it's option D. Moving on to one more. All the hydrides except one possesses the reducing property. Identify the hydride. Which of the hydride does not possess the reducing property? These are the hydrides of group 16 and it's only going to be water which does not show the reducing property, because in case of water, OH bond is stronger. OH bond does not break easily. If OH bond does not break easily, H2O does not give hydrogen easily. So H2O does not undergo oxidation easily. So H2O does not behave as the oxidizing agent easily. Sorry, reducing agent easily, yeah? Yes? Perfect? Right, people? Absolutely, it's going to be water. Yeah? Okay, moving on to one more. Sulfur in +3 oxygen state is present in dithionic acid, pyrosulfuric acid, sulfurous acid, thiosulfuric acid. You should remember their formulas as well as structures, right? And the correct answer is going to be dithionous acid, right? H2S2O4, correct? H2S2O4, H2S2O4, correct? And over here, if you calculate the oxidation state of sulfur, it's going to be +3. But I would want you guys to remember the structures of other compounds of sulfur as well. For example, pyrosulfuric acid, oleum, right? Sulfurous acid, H2SO3, right? Similarly, you have got thiosulfuric acid, H2S2O3. Do remember the structures. Anything can be asked. The question can be asked in this way as well. How many SOS linkages are present in case of H2SO4? Is there any peroxide linkage present in case of oleum, right? So this is something which you can only answer if you know the structures of these compounds, right? Moving on to one more. The incorrect characteristic of interhalogen compounds. Which of the following is the incorrect characteristic of interhalogen compounds? They are more reactive than halogens, which is absolutely right. Which is absolutely right. They are quite unstable because none of them is explosive. Absolutely right. They are covalent in nature. Absolutely right. They have low boiling points and are highly volatile. Is that? They do not have low boiling points, right? Yes? Yes, people? Perfect? Perfect? In case of interhalogen compounds, since they are covalent, right? But due to the electronegativity difference, they get the partial polar character, which makes their boiling point higher. Yes? Okay, and over here it's mentioned that they have got the low boiling point, which is not the case actually. Yeah, moving on to one more. Okay, so we are going to match these. Going to match these. BRF3. BRF3 is the compound which is given to me. Have a look exactly what I'm going to talk about. See, if I talk about BRF3, right? Boron, it's forming 3 bonds. Correct? I'm making its rough structure. This is the rough structure of BRF3. Sorry, it's not boron. It is bromine, right? sorry for that. Okay, bromine, it is first of all group 17 element. So it has got some 7 valence electrons, and out of 7 valence electrons, it has used 1, 2, and 3 for the bonding, right? Out of 7 valence electrons, it has used 1, 2, 3. 3 electrons it has used for bonding. So there will be 4 electrons left on bromine as such in the form of lone pair, right? So there will be 2 lone pairs on bromine. So 3 sigma bonds, 2 lone pair. 3 sigma bonds, 2 lone pair. The type of the molecule is going to be AB3L2, right? What is going to be the hybridization? 3 sigma bonds, 2 lone pairs. Hybridization is going to be sp3d, correct? Because the steric number is 5. What is going to be the geometry? Geometry is going to be trigonal bipyramidal, right? What about the shape? Shape is going to be T shape. These are the features of this BRF3. So just match it now. BRF3 molecule has dash trigonal bipyramidal geometry. Okay, and second, T shape, right? Third, lone pairs. How many lone pairs? 1, 2. 2 lone pairs on bromine. So option A is the one which is correct, right? Right, people? Absolutely, it's perfectly right. Let's move on to one more. Which of the following is correct order of nitrogen compounds in decreasing order of their oxidation states? So we need to calculate the oxidation state of nitrogen and arrange those oxidation states on the basis of their decreasing oxidation states, right? See, let's start with this nitrogen. Okay, let's start with HNO3. Hydrogen shows +1 oxygen state. Let's assume the oxygen state of nitrogen is X. Oxygen shows -2 oxygen state. There are 3 oxygen atoms. Net charge is 0. So X value will come out to be +5. So +5 is the oxidation state of nitrogen over here. In case of NO, it's going to be +2. In case of N2, it's going to be 0. In case of NH4Cl, right, it's going to be -3. Correct? Now arrange them on the basis of decreasing order, right? +5, 0. Sorry, +5, +2, 0, +3. So this is the decreasing order only. This is the decreasing order only which is given to me. Yeah? This is the decreasing order only which is given to me. Perfecto? So it's option A which is the correct answer of this question. Which of the following statement is incorrect? O3 is bent. Correct. OF2 is an oxide of fluorine. OF2 is an oxide of fluorine. People, do you think this statement is correct? OF2? Is OF2 the oxide of fluorine? Is OF2 the oxide of fluorine? It is not the oxide of fluorine. OF2 is the fluoride of oxygen. Yeah? OF2 is the fluoride of oxygen. It is not the oxide of fluorine. It is the fluoride of oxygen actually. Yeah? So it is absolutely going to be option B, which is the incorrect statement among all. Right? I'm not going to take the rest. Okay. When copper is heated with concentrated HNO3, it produces what? When copper is heated with concentrated HNO3, what does it produce? It is going to produce CuNO3 whole twice, and with that, you'll be getting NO2 gas as well. Yes? Right? The reaction is given in your NCERT, people. Okay? So it's option B which is going to be the correct answer of this question. Yeah? CuNO3 whole twice, and with this you are getting NO2 gas as well. So it's option B, and the reaction is given in NCERT, and this NO2 has got the brown color. Right? Perfecto? One more question. Water is much less volatile than H2S because water is much less volatile than H2S because in case of water there is hydrogen bonding, in case of H2S there is no hydrogen bonding, right? Okay, why is there no hydrogen bonding in H2S? Because the electronegativity difference between sulfur and oxygen is lesser than that of electronegativity difference between oxygen and hydrogen in case of water. So what is going to be the correct answer? What is going to be the correct answer? The correct answer is going to be H2O has got bond angle, nothing to do with this. Hydrogen is loosely bonded, nothing to do with this. Sulfur atom is less electronegative than oxygen atom. Sulfur atom is more electro. It's going to be option C, right? It is going to be option C, my dear people. Yes? Yes, you are doing it wrong, bro. It's going to be option C. Water is much less volatile than H2S because sulfur atom is less electronegative than oxygen atom, right? Hence does not form hydrogen bonding like water. Okay, let's move on to one more. H2SO4 is used in petroleum refining, absolutely right. Manufacturing of paints, pigments and dye stuff, correct. Detergent industry, yes, all the above. So what is going to be the answer? What is going to be the answer? I want you guys to let me know its answer. I want you guys to let me know its answer, my dear people. I want you guys to let me know its answer. It's absolutely going to be option D, right? Let's move on to one more question. Which of the following oxide is amphoteric in nature? The question directly given in NCERT. Is it going to be Al2O3? Absolutely, it's going to be Al2O3, which is amphoteric, right? It has got the acidic as well as the basic nature. Yes? Yes, which of the following is amphoteric in nature? It's going to be Al2O3, which is going to be amphoteric. Moving on to one more. The anomalous behavior of fluorine is due to its small size, correct one. Its highest electronegativity, correct one. Low FF bond dissociation and enthalpy, and non-availability of d orbitals of valence, absolutely right. So all the things are absolutely correct. So it's going to be D only, yeah? Yes, people, it's going to be D only. It's going to be D only, right? All the above. Okay, the blow reaction of chlorine prepared is of, what do we call this process? You're using CuCl2. Have a look, you're using CuCl2. What do we call this process? We call this process Deacon's process, right? We call this process Deacon's process, my dear people, right? The reaction is given into NCERT directly. Yes, it's called as Deacon's process. Okay, one more. Which of the following rare gas is most abundant in air? Helium, neon, argon, krypton. It's going to be argon, which is most abundant among all, right? It is going to be argon. Yes? Yes, people? Absolutely, it's going to be argon. Moving on to one more. And these are the abundances of these gases which are given to us by volume as well as by weight. You can check it out too. Okay? The structure of IF7. In case of IF7, how many sigma bonds do we have? We have got some 7 sigma bonds. Is there any lone pair on iodine? No. So sigma plus lone pair gives us the value of steric number. Steric number is going to be 7 plus 0. That is 7. So hybridization is going to be sp3d3, right? sp3d3. And do remember which d orbitals are involved in hybridization. It's going to be dxy, it's going to be dyz, it's going to be dzx. These are the d orbitals which are involved in hybridization. And at the same time, if hybridization is sp3d3, right, lone pair is 0, so shape and geometry is same, which is going to be pentagonal bipyramidal, right? Is there any option as pentagonal bipyramidal? Absolutely, it's option D, my dear people, right? Perfecto? Absolutely. Let's move into one more question. The following acids have been arranged in the order of their decreasing acidic strength. Identify the correct order. Identify the correct order from the given options. We are going to arrange them on the basis of their decreasing acidic strength. Over here, you've got chlorine, bromine, iodine. Which one is more electronegative? Chlorine, right? So with this acid is going to be the strongest among all. Yes? Right? So first, second, third, decreasing order. Correct? Yeah? You want me to go? You want me to move slow, or you are liking the speed? If you want me to go slow, I can slow. I can slow myself, right? What do you want? I'm asking you. Speed up? Yeah? Super fast? Okay, so I can see majority of the students are saying super fast, so let's move and jump into the super fast speed. Okay, one more. The number of SS bonds in sulfur trioxide. Is there any SS bond in sulfur trioxide? Trimer, S3O9. I'm asking you. The number of SS bonds in sulfur trioxide, S3O9. If you remember its structure, there is no SS bond. There is no SS bond, my dear people. And this is the structure. I want you guys to remember the structure. And I want you guys to remember the hybridization of this sulfur as well. It is forming 1, 2, 3, 4. 4 sigma bonds. So its hybridization is sp3. 4 sigma bonds, hybridization sp3. 4 sigma bonds, hybridization sp3. Right? Okay? There is no SS bond directly in case of your sulfur trioxide trimer. Yes? Okay? Perfect. The question can be, how many SOS bonds are there? How many SOS linkages are there? This is one SOS linkage, this is one more SOS linkage, this is one more SOS linkage. So there are 3 SOS linkages basically, right? Perfecto. Moving on to one more. Which of the following has OO linkage? Well. I can see the options and I can see the Marshall's acid over here, H2S2O8. If you remember its structure, in case of H2S2O8, the structure is going to be like this. Double bond O. How many oxygens we have? 8. So 2 more here. This is going to be oxygen attached with hydrogen. This is oxygen attached with hydrogen. So there is O single bond O, peroxide linkage in case of H2S2O8, right? Yes, Marshall's acid. Okay, moving on to one more. The number of p-pi d-pi bonds present in XeO3. If you remember the structure of XeO3, right, there are 3 double bonds like this, and there is a lone pair on xenon in case of XeO3, and in case of XeO4, what do we have? We have got 4 double bonds, correct? Okay, this pi bond over here, it's a p-pi d-pi bond. This is a p-pi d-pi bond. This is a p-pi d-pi bond. All the pi bonds are p-pi d-pi bonds. So in case of this, there are 3 p-pi d-pi bonds. And in case of this, 1, 2, 3 and 4, there are 4 p-pi d-pi bonds. So 3 and 4 is going to be the correct answer. 3 and 4 is going to be the correct answer, right? Yes, perfectly done. Absolutely. Let's move on directly to one more question. This is one more question. Compound X is formed when 3 parts of concentrated HCl and 1 part of concentrated HNO3 gets mixed. The correct option related to X. What is going to be X? X is something which we call as aqua regia, if you remember, right? Aqua regia, 3:1 ratio. Aqua regia. X is known as aqua regia. X is used for dissolving gold. This is correct for aqua regia too. Aqua regia is used to dissolve metals like gold, platinum, right? But all the metals are not dissolved. All the metals cannot be dissolved in aqua regia, right? There are some specific metals like gold, like platinum, which can be dissolved in aqua regia. So 1 is correct, B is correct. X is used for decomposition of salts of weak acid. No way. So both A and B. Both A and B is going to be the correct answer. So option D is your correct answer of this question, my dear people, right? Yes? Perfecto. Moving on to one more. Which of the following analogy is correct regarding... wait. There is something wrong. Over here, it is... Okay, it is NS2P3. Okay. I thought this option and this option are same. But the first one is NS2NP3. This one is NS2... The first one is NS2P3. The second one is NS2NP3. All right. If you talk about... Let's start with noble gases. Stable configuration, right? There is no configuration for noble gas. Yeah? Do you see P6 configuration? There is no P6 configuration, yeah? There is no NS2 NP6 configuration. Halogens will be having definitely NS2 NP5 configuration, right? NP5. Chalcogens means oxygen family. It's going to be NS2 NP4. Nicogens, nitrogen family. It's going to be NS2 NP3. Correct? Noble gases, it's going to have the configuration of NS2 NP6. These are the actual configurations of these groups, right? So just omit all these. Okay, just follow whatever I've written over here. NS2 NP3 for nicogens, for group 15, chalcogens group 16, NS2 NP4, halogens NS2 NP5, right? And noble gases NS2 NP6. Okay, perfect. I don't know what kind of option is given to us, right? Yes? Okay, so I'm sure you guys remember this. Let's jump into one more question. This is assertion reasoning now. F2 has higher reactivity than Cl2 instead of smaller size. Perfect. FF bond has low bond dissociation enthalpy than Cl bond. Correct, right? Yes. So what is going to be the answer of this question? Let me know fast. Let me know fast, people. It's a very simple one, right? It's a very simple one. First one is absolutely correct. F2 has higher reactivity than Cl2. This is correct. Second one is also correct. And the second one is the correct explanation of the first one, right? So A is going to be the correct answer. Assertion is true, reason is true. And the reason is the correct explanation of the assertion as well. Okay. Argon is used in arc welding because of its what? Low reactivity with metal, ability to lower the melting point of the metal, flammability, high calorific value. Can you let me know its answer? This question is again your NCERT question only. You guys can let me know fast. Someone is saying smoke is coming out of my mouth. Right, absolutely. The temperature right now is -1 or -2 degrees centigrade. I'm right now live from Srinagar, Jammu and Kashmir. Yeah, I hope you know that. Yes, so what is going to be the correct answer, people? It's going to be low reactivity with metal, right? Okay, so do remember this. Argon is used in welding in arc welding because of its low reactivity with the metal, right? Okay. Product formed will be XeF6 plus 2 times H2O. What is going to be the product? What is going to be the product? What is going to be the product, people? Isn't it going to be option A? Yes, it's going to be option A. Directly, the reaction is given in the NCERT again, right? XeF6 on hydrolysis, it gives what? XeO2F2, and with this you get HF as well. Okay. One more. Xenon hexafluoride reacts with silica to form a xenon compound X. The oxidation state of xenon is going to be, it's going to be +6, right? It's going to be +6. What is the reaction? Have a look at the reaction. Have a look at the reaction. XeF6 with SiO2 forms XeOF4. And when you calculate the oxidation state of xenon in XeOF4, it will come out to be +6. Yeah? I hope you are remembering this. Okay? Now let's move on to haloalkanes and arenes. You want me to start with haloalkanes and arenes right now, or you just want to take a break for 5 to 10 minutes? What do you want exactly? Tell me first. What do you want exactly? And the ones who have not liked the video yet, do like the video, share the video with your friends, and do subscribe to the channel. People, again I'm telling you, tomorrow, right after your examination at 1:45 sharp, I'll be coming live on NEET Elite English channel. Right? On NEET Elite English channel with the paper discussion. So do subscribe to that channel as well. I teach chemistry on that channel as well. NEET Elite English. Okay? Let me tell you the name again. It is NEET Elite English channel, right? I'll be coming up with the paper discussion for your CBSE Term 1 tomorrow at 1:45 live on this, okay? Yes, so do subscribe to the channel right now. Let me see exactly, are you actually subscribing the channel or not? So that, let me first of all see, have you actually done it or not? Let me see first. Well, the session is simulcasted on NEET Elite channel as well, wonderful. So let me quickly see, have you actually subscribed? You guys have not done yet. Do it fast. Okay, I'm not going to take any sort of break. Yeah? But I want you guys to subscribe to NEET Elite channel right now, my dear people. Yes? Okay? Just give me a second. People are saying no break. All right, people. Let's not take any break. Yeah? Right? So just let me know in the chats, have you subscribed to NEET Elite? I'm asking you, have you subscribed? Honestly, you can say yes or no. I'm not going to start unless. Yeah? Well, I can see only few people have done that. I want honest answers, people. I want honest answers. I don't want you to bluff with your teacher, yeah? Well, majority of the students are saying, yes, you're subscribed. Let me check it out. Okay, I've got the phone in my hand only. Wonderful, guys. Good job done. This is my army now, yeah? Okay, so let's move on. Let's move on then, yes? Let's move on. Let's not take any sort of break. Okay, this is the first reaction which is given to us. We are supposed to see X. What is this X, right? You're starting with alkyl chloride, ethyl chloride, okay, with X, and you're getting alcohol, right? From alkyl halide to alcohol, what do you need? What do you need? Do you need alcoholic KOH? Do you need alcoholic KOH, right? Or aqueous KOH? What do you need exactly? What do you need exactly, my dear people? You exactly need aqueous KOH, right? In order to convert your alkyl halide into the alcohol, right? The reaction is simple, given in the NCERT itself. When ethyl chloride is boiled with KOH, then ethyl alcohol is prepared, right? This is aqueous KOH which we are using over here. Yes? Okay, one more. IUPAC name of the following compound. Let's give it the IUPAC name. This is your carbon number 1, this is 2, this is 3, this is 4, this is 5. So it's going to be 4-bromopent-2-ene, right? 4-bromopent-2-ene. Yes, this is the option. So option C is the one which is correct, right? Absolutely, killed it. One more. Okay, when ethyl chloride reacts with thionyl chloride in presence of pyridine, the product obtained is, in the product you'll be having two gaseous products. You'll be having two gaseous byproducts, if you remember. You'll be having two gaseous byproducts. Yes, what is going to be that? What is going to be it? What is going to be the correct answer of this one? Fast, 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 fast. You're making your ethyl alcohol to react with ethional chloride, SOCl2. What is going to be the product? I'm looking at the chats only. Absolutely, people, it's going to be option B. So you get chloroethane, sulfur dioxide gas, hydrochloric, HCl gas as well. Yeah? So do remember this. And this is again the question from your NCERT. One more. Which of the following reactants are used in Finn-Claisen reaction? In case of Finn-Claisen reaction, which of the following reactant is used? It is going to be sodium iodide and ethyl bromide, right? Yes. In your Finn-Claisen reaction, if you remember, you use sodium iodide and ethyl bromide, right? Yes, people. It's option D, which is going to be the correct answer of this one. One more. Which of the following statement is true? First of all, you're making this ethyl chloride to react with AgCN. What is the product which you are getting? What is the major product? Major product will be C2H5. It is going to be NC, right? It is isocyanide. It is isocyanide. Yes? It is isocyanide. It is isocyanide. Now look at the options. It gives propanoic acid on hydrolysis. It has an ester in the functional group. It has nitrogen linked with ethyl carbon. Nitrogen is linked actually with ethyl carbon. Absolutely right. It's option C, which is the correct answer of this question. Yes, people? Yes? Right? Option C is the one which is correct. It is isocyanide. It is NC. This nitrogen is linked with the carbon of this ethyl. Yes? Okay? One more. The set of compounds in which the reactivity of halogen atom is in ascending order. The set of compounds in which the reactivity of halogen atom is in ascending order. We have got vinyl chloride. We have got chloroethane. We have got chlorobenzene. Well, I can see two compounds, vinyl chloride and chlorobenzene, right? In vinyl chloride and chlorobenzene, there will be a partial double bond between carbon and chlorine, right? Between carbon and chlorine, which makes it less reactive. So more reactive chlorine will be in chloroethane, followed by vinyl chloride, followed by chlorobenzene, right? Yes. So chloroethane will have the maximum reactive chlorine, followed by your vinyl chloride, followed by your chlorobenzene, right? So option D is the one which is correct. Yeah. Have a look. In chlorobenzene and vinyl chloride, the CCl bond acquires some double bond character due to resonance. Absolutely. Hence, they are less reactive than chloroethane. Thus, the order of reactivity of halogens becomes this, right? Moving on to one more. Can you let me know the answer of this question fast? Which of the following species will be most reactive towards SN2? SN2 reaction, right? One-step reaction. You need to see the order of what? You need to see which of the following will be most reactive towards SN2. Wherever steric hindrance will be less, that is absolutely going to be most reactive. Wherever steric hindrance is less, that's going to be most reactive. Steric hindrance is least in the first case, so A is going to be the most reactive towards SN2, right? A is going to be most reactive towards SN2. Which of the following is the example of Wurtz-Fittig reaction? Wurtz-Fittig reaction. This cannot be a C6H5I, and what you are getting, copper you are using, no. So C6H5I, sodium, you are getting toluene over here. Yes, option C is the one which is the example of the Wurtz-Fittig reaction, right, people? The reaction directly given in your NCERT. Yeah, option C. This is your Wurtz-Fittig reaction. Okay, one more. Which of the following is the example of vicinal dihalide? 1,2-dichloroethane, correct? 1,2-dichloroethane is the example of what? It is the example of vicinal dihalide, and this is its structure as well. This is 1,2-dichloroethane. Yeah. Perfect. Absolutely. One more. The formula of gem dibromide. In case of gem dibromide, two bromine atoms will be attached on the same carbon. Two bromine atoms will be attached on the same carbon. So two bromine atoms are attached differently. Two bromine atoms are attached at the same carbon. Have a look at the option C. At option C, do we have two bromines attached on the same carbon? Absolutely. So option C is the example of your gem dibromide, geminal dibromide, right? Yes. One more. 2-bromobutane on dehydrobromination gives this, which is also called as, okay. So we are starting with 2-bromobutane, right? We are starting with 2-bromobutane, correct? This is your 2-bromobutane first of all, correct? On dehydrobromination, it is giving this. This is the product it's giving, right? So first of all, on dehydrobromination, what it's going to give? How you are going to make the products first of all? How you are going to make the products of this substrate? First of all, I'll be removing this Br. if I remove this Br, there will be a positive charge coming on this carbon, right? I'll be calling this is alpha carbon, this is beta, this is beta. Now two types of products can be formed. Either you can take H positive out from this beta carbon or from this beta carbon. If you are taking H positive out of this beta carbon, the product is going to be CH3, CH double bond, CH single bond CH3. And if you are taking H positive out from this carbon, the product is going to be CH2. There will be a double bond over here at this position. It's going to be CH, it's going to be CH2, it's going to be CH3. These are the two products which you'll be getting. One of them is Sage-Ziff, one of them is Hoffman. Which one is Sage-Ziff and which one is Hoffman? The one at which the double bond is more stabilized by the more alpha hydrogens. Over here, double bond is stabilized by 3 and 3, 6 alpha hydrogens. Over here, double bond is stabilized by only 2 alpha hydrogens. Right? So this one is more stable. So this is the product which you are getting, and it is called as Sage-Ziff's product, right? Okay, so what is going to be the correct answer? It's going to be Sage-Ziff product. Yeah? Perfect, people? I'm sure you would have studied Sage-Ziff Hoffman products. Okay? Moving on to one more. The below reaction is also known as, what do we call this reaction? Well, you're using pyridine over here, SOCl2 and your ethanol. Correct? What do we call this reaction as? Do we call this as the Darzin's process? Do we call this as the Darzin's process? Yes. Yes. Absolutely, we call this as the Darzin's process. Right? What is the correct order of reactivity of alcohols in the following? Reactivity of alcohols in the following. Yes? Can you let me know first? Can you let me know first? Can you let me know first? So first of all, make the carbocation. Make the carbocation. Now, depending on the stability of the carbocation, you can decide the rate. Right? You can decide the rate. 3 degree carbocation will be absolutely maximum stable. So wherever in the substrate you are getting 3 degree carbocation, that is absolutely going to show more rate towards SN1. Yeah? Okay? Isn't it a Lucas test? I mean, over here you are using ROH, correct? You are using ROH. So first of all, make a carbocation over here. Put a positive charge on this R, right? The carbocation which gets generated over here, that's R positive, correct? Now, depending on the stability of this carbocation, you can decide the reactivity, okay? 3 degree carbocation is maximum stable, followed by 2 degree, followed by 1 degree, right? So whatever is going to be the stability order of the carbocations, same is going to be the reactivity of the substrates, right? Yes, so what is going to be the correct answer? It's option C, people. Yes. Okay, which of the following reaction will not yield phenol? You're using chlorobenzene, fusion with NaOH at 300, then acidic hydrolysis. Over here in this reaction, you will be getting phenol. Yes. This is the example of diazotization reaction. Finally, you'll be getting phenol, right? You're using oleum over here, and then NaOH heating H positive. Again over here, you'll be getting the phenol. In case of the last one, you are using NaOH 298 Kelvin, 1 atm. Okay, I think last one is not going to yield the phenol. Why is that? Because this reaction takes place under drastic conditions, right? The temperature is approximately around 610, 13, something like that. But over here, temperature is given as 298 Kelvin. This reaction actually takes place what? It takes place under drastic conditions, and the drastic conditions are not given. Yes, so option D is the one which is not going to yield phenol. Let's check it out. Yes, it's option D, and these are actually the reactions which take place. Okay, so the reaction of option D will not yield phenol. It's a nucleophilic substitution of chlorobenzene, which requires drastic conditions, high temperature of 613 Kelvin and high pressure of 300 atm, which was not given to us, right? Okay, X and Y respectively are. X and Y respectively are. X and Y respectively are. You are using alcoholic KOH, right? So first of all, remove this I negative. There will be a positive charge over here. This is alpha carbon. This is beta carbon. From beta carbon, just take H positive out. So you'll be getting the final product as CH3. This is CH. This is double bond. This is CH, right? This is your X. This is your X. Now this X on reaction with Br2, what you'll be getting? Just break this double bond. If you break this double bond, you'll be getting CH3. CH with this carbon, one bromine will get attached. With the other carbon, one more bromine will be getting attached, right? Yes? Correct? Okay, so what is X and what is Y? Check. What is X and what's Y? This is actually X, this X, but this is not Y. This is X and this is Y. Correct? So option D is the one which is correct. Yes? I'm sure you're following it. Okay, one more question. Toluene on reaction with Cl2 in presence of FeCl3 gives predominantly what? In the last session also we have solved this question if you remember. Toluene on reaction with Cl2 in presence of Fe tripositive, right? It gives predominantly ortho and parachlorotoluene, right? It gives predominantly ortho and parachlorotoluene. This is parachlorotoluene, this is your orthochlorotoluene, right? Yes, absolutely guys, all of you are perfectly right. I'm moving on directly to one more. The structure of the major product formed in the given reaction. Okay, you're using NaCN DMF as the reagent over here. So what is going to happen? Simply just replace this chlorine with CN and you are getting the product finally like this. Right? This iodine, nothing to do with this one, right? This is your CN. This is the final product. Just replace chlorine with CN, that's all. So which option is it? Which option is it? It's option D. Yeah? Okay, one more. Increasing order of SN1 reaction in the following compounds. Yes, increasing order of SN1 reaction in the following compounds is given to me. C maximum, A, then B. First of all, in SN1 reaction, what is the first step? We get the carbocation, right? Over here, when you take I negative out, the carbocation will be over here, positive charge. Take I negative out, there will be a positive charge on this carbon. Right? Take I negative out, positive charge on this carbon. Now take the stability of the carbocation first of all, right? This CH3, it will show plus H effect. Plus H effect stabilizes the carbocation. This is OMe, right? It is attached at the meta position. At meta position, it's going to operate minus I. It's not going to operate plus N, right? Okay, and we know plus effect stabilize the carbocation. So which carbocation is maximum stable? C is maximum stable carbocation followed by A followed by B, right? This is the stability order of carbocation, and same is going to be the reactivity of these substrates towards SN1, right? CAB, yes, absolutely, it's right. Second, more stable is the carbocation intermediate, higher will be the rate of SN1 reaction. Absolutely right. Absolutely right. So option A. Yeah? Absolutely, people. Okay, one more. Aryl halide cannot be prepared by replacement of hydroxyl group of phenol by halogen. Reason? Carbon-oxygen bond in phenol has partial double bond character. Assertion is correct, reason is correct, and the reason is the correct explanation of the assertion as well. Yeah? Right? In case of your aryl halides, between carbon and halogen, due to resonance, you get the partial double bond character, due to which it is difficult to remove chlorine. Right? Yes? Right. Okay? So it was option A. Benzyl bromide, when kept in acetone and water, produces benzyl alcohol. It's absolutely correct. Whenever benzyl bromide will be kept in acetone and water, it produces benzyl alcohol. Reason? The reaction follows SN2 mechanism. Right? Yes? Right? Right, people? Yes, what is going to be its answer? You all are right. Yes, absolutely. Absolutely. Let me just have some water first. My throat is aching a bit. Till then, you can solve the first question of alcohol phenol ether, right? You can let me know its answer. Till then, I can have some water. What is going to be its correct answer? Fast. Okay, so we have got an organic compound. People, I want answers from everyone. I want answers from everyone. Let me know its answer fast in the chats. Yes. I want you guys to flood the chat box with the correct answers. Absolutely, majority of the students are giving the correct answer. It is absolutely going to be an alcohol, right? An organic compound dissolved in dry benzene, evolved hydrogen on treatment with sodium. It's absolutely going to be an alcohol, right? It's absolutely going to be alcohol. Alcohol with sodium in presence of dry benzene. It gives you RONA, and with this H2 gas is liberated, right? Yes? Okay. Which of the following product is formed when phenyl magnesium bromide reacts with methanol? So when phenyl magnesium bromide, right? When phenyl magnesium bromide will be reacting with methanol, when phenyl magnesium bromide will be reacting with methanol, what is something which you'll be getting? First of all, you'll be getting a benzene, right? From here, you'll be getting benzene first of all. And apart from benzene, what do we get? You'll be getting Mg, it's going to be OCH3, right? It's going to be Br. These are the two products. Now check it out. You will be getting a mixture of benzene and MgOCH3Br. MgOCH3Br. That means MgOMeBr. This one is correct. Option C is the one which is correct among all. Yes, Muhammad Yusuf, you're absolutely right. Okay, one more. Okay, we are starting with the 1 degree alcohol, right? On reaction with copper, what it's going to give, right? So alcohol, 1 degree alcohol, in presence of copper and heating it up, it's going to get converted into the aldehyde, right? It's going to get converted into aldehyde. So this is first of all your alcohol. So this A is going to be aldehyde. On reaction with Al2O3, what it's going to give? So on reaction with Al2O3 in presence of heat, okay, it is going to get converted into alkene. It's going to get converted into alkene. So A is going to be aldehyde, B is going to be alkene. A is going to be aldehyde, alkenyl, and B is going to be alkene. Absolutely option 1 is the correct answer of this question. Yes? Absolutely option 1 is the correct answer of this question. So ethanol on reaction with copper in heat, it is going to give the aldehyde, right? And this one is ethene. Okay? My head is aching a lot. Okay, we are starting with something as A. We are using the strong oxidizing agent K2Cr2O7. It's getting converted into acetone, right? Then on further oxidation, you are getting the acetic acid. What is this A? This is very simple. It should be 2 degree alcohol, right? It should be 2 degree alcohol. Is that? Is it 2 butanol or 2 propanol? Can you let me know in the answers? Can you let me know in the chats? Is it going to be 2 butanol or 2 propanol? You are getting acetone basically, right? You are getting CH3, C double bond O, CH3, correct? You are getting acetone, right? 3 carbon atoms. So you'll be starting with CH3, this is C, this is OH, right? And this is CH3. You'll be starting with 2 propanol, right? 2 propanol only will be giving you acetone, and acetone will be giving you what? It's going to give you acetic acid, right? So option C is absolutely the one which is correct. You'll be starting with 2 propanol, right? You'll be getting acetone, and finally you'll be getting the acetic acid. Yes? Okay, the reagent that converts propene to 1 propanol. Propene, okay, alkene to alcohol. Alkene to alcohol, that too 1 degree alcohol, right? So what kind of reaction is this? People, do you remember this is hydroboration reaction? Yes? Do you remember this is hydroboration reaction? And in the hydroboration reaction, what is going to be the reagent which we use? Isn't it option D? Isn't it option D, B2H6, H2O2, H negative, right? Is it option D? Yes, Ritvik, it's hydroboration reaction, and over here, option D is going to be the reagent. The product formed in the following reaction will be, what is the product formed? What is the product formed? What is the product formed? Well, the product should be C6H5OCH3, okay? Right? With HI in presence of heat. So, simply do one thing. The final product is going to be C6H5. This is O. With this oxygen, you are going to attach this H, right? And this with this CH3, just attach this I. So CH3I. These are the 2 products. Just check the options. C6H5OH, that is phenol, and methyl iodide. Option D is the one which is correct, right? Absolutely, people. Option D is the one which is correct. Okay. One more. In CH2OH, the bond that undergoes heterolytic cleavage most easily. Which bond will undergo heterolytic cleavage more easily? Wherever the electronegativity difference is more, that bond only will be showing the heterolytic cleavage easily. So it's going to be option D. In case of OH, the electronegativity difference is maximum, so this will undergo cleavage easily, right? Yes, it's going to be option D. OH, due to more electronegativity difference. Which of the following reagent is used to reduce carboxylic acids to primary alcohols? Carboxylic acid to primary alcohols. It's going to be lithium aluminum hydride, right? Yes, LiAlH4. Absolutely. Yes, lithium aluminum hydride is the one. Okay, the alcohol that produces turbidity immediately with Lucas reagent at room temperature. Simple, it should be a 3-degree alcohol, right? So which of the following is the 3-degree alcohol? Which of the following is the 3-degree alcohol? 1 hydroxybutane, no way. 2 hydroxybutane, no way. 2 hydroxy, 2 methyl propane. So it's going to be option C, right? It's going to be option C. Hitansh, temperature right now in Kashmir is -2 degrees centigrade, right? Okay? That's why you can see there'll be smoke coming out of my mouth. Fog. Okay? Perfect. Moving on to one more. Select the incorrect statement about Kolb's reaction. Incorrect statement about Kolb's reaction. Phenoxide ion is less reactive than phenol towards electrophilic aromatic substitution. Is it right or wrong? Let me know. You guys let me know. Is option 1 right or wrong? This is incorrect, right? Phenoxide ion, it is more reactive than phenol, right? Towards the electrophilic aromatic substitution. Correct? Yes? Due to resonance, if you remember. Right? So, the conversion of metanitrophenol to resorcinol involves respectively. We are starting with metanitrophenol. We are starting with metanitrophenol, correct? What we need to get at the end, we need resorcinol. Resorcinol means instead of NO2, there should be OH, right? That's resorcinol. So what is the process which I'll be doing? So first of all, let me do the reduction. Let me do the reduction. If I do the reduction, what is the product which you'll be getting? You'll be getting the product like this. This is OH, and instead of NO2, you'll be getting NH2, right? After reduction, if I do the diazotization, right? If I do the diazotization, what do I get as a product? This is the product which I'll be getting. This is your OH, and over here at meta position, this is going to be N2Cl, right? It's going to be N2Cl. And once you get this diazonium chloride, I'll be doing the hydrolysis. After doing the hydrolysis, you'll be getting what? Instead of N2Cl at meta position, you are going to attach OH. So these are the 3 steps. First was reduction, second is diazotization, third is simple hydrolysis. Right? So check it out. Hydrolysis, reduction, diazotization, hydrolysis. Reduction, diazotization, hydrolysis. Yes? Perfect? Right? So option D is the one. Okay, which of the following alcohols gives the best yield for dialkyl ether on being heated with a trace of sulfuric acid? This question you can solve on your own, right? Well, I'm looking at your chats. You guys can let me know the correct answer of this question. Yeah? Just let me know fast. Just let me know fast. It's a very simple one, right? What is the correct answer? Is it going to be 1-pentanol? Is it going to be 1-pentanol? Is that? One-degree alcohols readily formed ethers when heated with concentrated H2SO4, right? Yes? Okay? And over here, you have got 1-pentanol, which is basically a 1-degree alcohol. Yeah? The boiling point of alcohol is higher than ether. This is right. Why is that? Because in alcohols, we have got hydrogen bonds. In ethers, there is not the hydrogen bonds. There is no hydrogen bond in ether. A is right. Reason is right. Reason is the correct explanation of the assertion. Right? Yes, people? Okay. But what is the role of Grignard's reagent? Can you let me know what is the role of Grignard's reagent? Case study questions you'll be getting definitely. Role of Grignard's reagent. Is it going to be remove carbon-carbon bond or form carbon-carbon bond? What do you think? What do you think? Yes, it's going to be form, right? To form new carbon-carbon bonds. That's the role of Grignard's reagent. Grignard's reagent is used in organic reactions to form new carbon-carbon bonds. It is useful to form alcohols from ketones and aldehydes. That's something which every one of you would be knowing. Which of the following major product is formed when phenol is treated with sodium hydroxide and carbon dioxide? A very famous reaction this is. A very famous reaction this is. What is it? Do you get salicylic acid or salicyldehyde? Do you get salicylic acid in this reaction or salicyldehyde? Very famous reaction, absolutely. You have flooded the chat box with the correct answer. Yes, it's Kolb's one, right? You get salicylic acid, right? Okay. Among the given compounds, one with which most easily attacked by electrophile. Which of the following will get easily attacked by the electrophile? Where do you see the electron density maximum? Electron density will be maximum in the first ring, because you have got OH. OH has got more tendency to increase the electron density in the ring, right? Yes. So electrophile would love to attack here. Option A. Yes. Okay. The last chapter, that is biomolecules, right? That is biomolecules. I think I'll sit and do it, because biomolecules, there is nothing as such, right? Let me show you the questions and you guys will be letting me know the answers in the comment section, okay? The first question, can you let me know its answer fast? Can you let me know its answer fast? A nucleoside on hydrolysis gives, what does it give? An aldopentose and phosphoric acid, an aldopentose and a nitrogenous base, an aldopentose and nitrogenous base and phosphoric acid, a nitrogenous base and phosphoric acid. What do you think about this one, people? What do you think about this one? Fast. Well, I can see majority of the students are coming with option B, and absolutely it's going to be option B only, right? So nucleoside on hydrolysis gives aldopentose and a nitrogenous base which has heterocyclic ring, right? Heterocyclic amino acid. Which of the following is the heterocyclic amino acid? I think it's option A, right? Tryptophan. Yes. Option A is the one which is correct for this. Yes. Okay, glucose plus Tolman's reagent gives silver mirror. The above process shows. It shows the presence of CHO group, right? Yes. It shows the presence. Glucose plus Tolman's reagent. It gives silver mirror. The above process shows what? The presence of CHO group. I hope you know it. Right? The session is not going to take more than 5 minutes. Okay. Which of the following statement is incorrect? Glucose exists in two crystalline forms, alpha and beta. This is correct. The cyclic structure of glucose is correctly represented by Haworth structure. Correct. 5-membered cyclic structure of glucose is called as pyranose. No way. It is the 6-membered cyclic structure which is called as pyranose, right? And over here it's mentioned that 5-membered ring is called as pyranose. No. So option C is the incorrect, right? Option C is the incorrect one. Which of the following reactions are not shown by glucose? Reaction with NH3. Glucose does not show reaction with NH3. Correct only. Right? Reaction with 2,4-DNP reagent. It does not show reaction with it as well. Reaction with Grignard's reagent. No way. All of these is going to be the correct answer. Right? Glucose does not show any reaction with any of these reagents. Right? All the given reactions are not shown by glucose because glucose is a cyclic compound. Its aldehyde group is not free at all. Okay? Which of the following statement is not correct about the amino acids? Well, it's mentioned over here, there are 25 essential amino acids. Are there 25 essential amino acids or 9 essential amino acids? There are only 9 essential amino acids, right? So it's option B, which is incorrect, right? Okay? Yes. One more. Which of the following amino acid is not optically active? Is it lysine or glycine? Let me know fast. Which of the following is not optically active? It is going to be glycine, right? Because it does not have any chiral carbon. Okay? Because you have got two same groups attached with this carbon over here. Yeah? Okay, glucose and galactose are having identical configuration in all positions except which carbon? Isn't it going to be carbon number 4? Right? Isn't it going to be carbon number 4? Look at carbon number 4. Configuration of OH. On the right side, configuration of OH on the left side, right? At carbon number 4, there's a difference between the D-glucose and D-galactose. Which of the following is the best matched options? Okay, amino acid forms a zwitterion, right? A, attach with 4. Thymine, part of DNA, right? Insulin, you're going to attach with it. You're going to attach it with protein, right? Phosphodiester linkage is going to be in nucleic acid, right? Isn't it going to be option B, people? Isn't it going to be option B? Yes? Right? It's absolutely going to be option B, and this table is given in your NCERT as well. Which of the following statement is incorrect about amino acids? Well, as I can see, amino acids are usually colorless, crystalline solids. What do I have to see? Which of the following statement is incorrect? This one is correct. They are soluble in water. Absolutely, they are soluble in water. Amino acids. They behave like salts. Yes, they behave like salts. Melting points of amino acids are very low. Is it right? Is it right? What do you think? Melting point of amino acids is high. It's not very low. Right? Yes, due to high intra-ionic attractions. Due to high ionic interaction, sorry. Which of the following, the nitrogen base which is present in RNA and absent in DNA. Which one is that? In RNA, your thymine is replaced by uracil, right? In RNA, thymine is replaced by uracil, if you remember, right? Yes? So which one is uracil among all? It's option D. Yeah? Option D is absolutely the correct answer of this one as well. Okay, which of the following analogy is correct? Monosaccharides, glucose, polysaccharide, glycogen. Absolutely option 1 only. Yeah? Option 1 only. Assertion: glucose gets oxidized to gluconic acid on reaction with mild oxidizing agent, which is absolutely correct. Glucose contains the ester group. Glucose does not contain the ester group, right? Okay, assertion is right, reason is wrong. Assertion is right, reason is wrong. Protein are made up of alpha amino acids. During denaturation, secondary and tertiary structure of protein are destroyed. What do you think about this one? What do you think about this one? Tell me its answer fast, people. Definitely both the statements are correct and your reason is not the actual correct explanation of the assertion, right? Chemically, protein are polymers in which the monomeric units are alpha amino acids. That is the correct explanation of the assertion. And with this, I'm sure your whole syllabus would have got revised properly, right? Yes, and I'm damn sure you guys are going to kill it tomorrow. And you guys will be joining me tomorrow at 1:45 sharp. I'll be taking live session in which I'll be interacting with you about the paper, right? It's going to be the paper interaction tomorrow at 1:45 on live from NEET Elite channel tomorrow, right? Yes? Okay, and if you have not liked the video yet, please do like the video, share the video with friends, and do subscribe to the channel, and do mention in the comment section if you like the video or not. And the ones who have not enrolled into the JEE 2022 batch yet, do enroll as soon as possible by taking any of these pro subscriptions. You can take any of these pro subscriptions just to check, right? Just to check whether, you can take any of these pro subscriptions for 15 days just to have a look on the actual Vedantu platform, just to see whether you guys are going to get benefited from that batch, which is going to start on the actual Vedantu platform, right? You can take any of these subscriptions and the cost of it is going to be completely affordable, right? Any pro subscription you can take, okay, right? And this is basically for the ones who are going to write the JEE in 2022. It is my personal suggestion for you guys to get enrolled into the long-term batch, into the actual batch on the actual Vedantu platform by taking any of these pro subscriptions, right? You can take the subscriptions for 15 days just to have a look on the actual classes, just to see whether you are getting benefited, and trust me, you're going to love it, because the study material, the teachers which you'll be getting on the actual Vedantu platform, they are really very good, right? They are actually the subject experts who will be helping you out in training you for the upcoming JEE 2022 examination, right? And let me show you exactly how to get enrolled in this. Okay, so the ones who are looking for the crash course, right? Vedantu has given you the 50% off right now. It's more than 50% actually, right? You're just getting the crash course for JEE 2022 for just 9K. Link is there in the description box of the video, and you're going to use the coupon code WBPRO in order to get further discount. And let me show you exactly how to get enrolled in this one. How to get enrolled into the batch which is going to start on the actual Vedantu platform, be it crash course, be it whatever, right? See guys, you need to drag the video a little down, click on show more. After clicking on show more, you'll be getting a lot of links over here, right? Class 12th JEE 2022. I'm clicking, for example, on this link or JEE Dropper, whatever link you want to click on. For example, I'm clicking on JEE 2022, right? Over here, you'll be having 3 links, first, second, and third. For example, I'm taking light plan and I need to try it out, for example, for 15 days. I'll be clicking on this try for 15 days and using the coupon code WBPRO, giving my number on which you'll be getting the OTP and everything, right? And eventually you'll be getting enrolled into the actual batch, which is there on the actual Vedantu platform. Trust me, you're going to love it. Do get enrolled as soon as possible, right? And do not forget to like the video, share the video with friends, and do not forget to subscribe to the channel. And do not forget to subscribe to the NEET Elite channel as well, because tomorrow I'm coming live from that channel only, okay? Yes. So with this, I'm taking a leave. I'll see you guys tomorrow at 1:45. Till then, you guys take care. Bye-bye. God bless you all and love you all and all the very best. Do kill it and let's meet up tomorrow. Take care, guys. Bye.